Okay, let's start with that. This is ignition systems. We are looking at which statement below is correct. Ignition system, you guys know how they work. You know how a coil takes 12 volts and turns it into 100,000? Anybody know that? Anybody can explain that? What you got that speedometer in your hand for? Put that down.
Yeah,
huh?
Yeah.
Yeah, put that somewhere else. But anyway, you know how that works, right? Anybody know how it works?
It's usually spinning it. Spin it real fast, therefore magnifies it like Mr. Bigger.
You talking about a magneto or what?
No.
All right. If I got my coil here, this is a sort of a basic thing, and I got two little terminals. I got a minus and a plus. And this one here is actually the big one that's going out to create your spark. You know it's going to be firing to ground right there. All right, then this one here is going to get about 8 volts usually through a ballast resistor of some kind. This is the old oil-filled coil like I got on that acrylic over there. Right. And I got to get that stuff in order. It's all fouled up. Somebody's been playing around with my stuff over there. Anyway, if you take a set of points right here, and you're going to put a ground in here. This is very simple. There's also a capacitor in there, but to keep it simple, I'm not going to draw that. All right. In this side, inside of this thing, you've got a hook to this. You got a winding. It's got not all that many wraps. All right. And this one here, you've got a winding. It's got lots and lots of wraps. I mean, lots of them.
Come on, the big one? I mean,
yeah, the secondary has got lots of little bitty wraps. There are lots and lots of them. And there's a metal core inside here to magnify this. All right, so when you energize this primary winding, which is the one that, you know, is fed with these two, then you're going to make a magnetic field that's going to be really strong. And when that magnetic field saturates that coil, most of your new modules stop feeding current to it because they don't want to burn it up. They limit it to a certain number of amps. When you break that, in other words, when you break that connection and this magnetic field collapses, the magnetic field, when it sweeps across that winding and it's got all them other wraps in it, it creates a spark that can be 100, 120,000 volts.
So the point has to break.
When it breaks and it collapses that field, that's how your ignition system creates a spark.
Okay,
it's basically a step-up transformer, but it's changing the voltage. You're trading amps for voltage and that kind of thing. So you got a few wraps on your primary side, a lot of wraps on your secondary side. And on anything, if you're talking about primary and secondary sides of a circuit, the primary side is what triggers it. The secondary side is where things take place. On a relay, the coil is the primary side, and the contacts are the secondary side, because the secondary side is what does the work. That's how an ignition system works basically. Now, there's some variations of it.
Without points in it?
Huh? Yes, you can do that. Basically, the one that without points in it has got a transistor that does this same job. And a transistor is nothing more than a switch that doesn't have moving parts, you know. And so a transistor, what you do with a transistor is you're going to have it's going to look like this. That's actually a symbol for a transistor. And on a PNP transistor, this is positive, and this is negative, and that's negative. So let's say that you're feeding a ground in there, and that ground is actually going to fire your coil. When you send a positive pulse into that transistor, then it's going to cause that coil to fire.
So instead of it being grounded on this side, it's going to be having.
Yeah, but if it's got an NPN, it could go the other way. But the point is, that's how they do it with the transistor and the trigger wheel in the distributor. Your reluctor does it, or if you've got a crank pickup and the PCM's doing it, transistors are the name of the game when you got electronic. And there's some capacitors and stuff in there too. But that's how that stuff works. All right. That's just a basic overview of it. I mean, it's you know, if somebody's a real stickler for accuracy, they're going to say, well, you got this wrong and that wrong. But basically, the simple principle is saturate the coil with magnetism, break the connection, pop. You get a pop. I'm going to show you that on a bench over here in a minute. I got some ignition parts, and we can make a spark pop over here by just, you know, getting the parts and making it happen. I think Tyler's probably seen me do that before, but anyway. But most ignition systems work by switching the circuit grounding the ignition coil's primary windings. Is that true or false?
Oh, no.
Huh? Most ignition systems work by switching the circuit grounding the ignition coil's primary windings. What did I just draw up here, guys?
Okay.
the circuit, grounding the ignition coil, primary winding. Most ignition systems work. That was A. Most ignition systems work by switching the circuit to power the ignition coil's primary windings. Now, the reason I say most ignition systems, you guys, you gearheads that like to race, you know these multiple start, park, discharge systems and all that. Yeah. Put your head up, Tyler. What Tyler does is he puts his phone on his knee and puts his head down and he texts it. I know, I got you figured out. All right.
He ain't doing it right now.
Yeah, well, don't put your head down. What you're doing with your head down is illegitimate. Okay. Most ignition systems work by switching the current power ignition coil. These are big, long answers. That's kind of dumb. So, who got an idea of what kind of answer we got there? That's going to be A, isn't it? Now, the multiple spark discharge system, like you use on race cars, switches the hot side. Then they're making a stronger spark that way, or it works faster or something. All right. Now that's going to be A. Which of these terms are specified by the Society of Automotive Engineers as a term describing an ignition system that does not use a distributor? DI, IGN, EI, or ND? What do you think?
Yeah. Electronic ignition.
And so that one there is going to be a C, isn't it? All right. 3. The ignition system pickup coil or trigger is usually connected to which device? This is one, if it's got a distributor, the ignition system pickup coil or trigger is usually connected to which device? My goodness. Y'all are scaring me now.
I know it's the rotary.
All right, now does, no. Well, let me get a distributor over here. This distributor here came out of a Ford that's older than the one that Jeremy's wondering about. All right. Yeah. Now this thing right here, see that little reluctor? This is a pickup coil here. And coming out of that pickup coil, you got 2 wires. The third wire is a ground wire that gives us ground from right here in that thing. See, the ground wire from right there feeds that ground. All right. Let me see if I can sign this ticket here. And Kathy, you could just stay here in this cool room with us and learn all about this stuff, couldn't you? All right. Put all that stuff on the desk, including the valve stems.
Okay.
All right. You know any valve stem seals up there?
Yeah.
That's part of an engine. I'm just giving you a hard time. Okay. All right. But anyway, you see this?
Yeah, we do have.
Yeah. So look at these wires here. Now, what are these connected to? Now, we're dropping back from that. Let me make sure I got my parts here. You see this right here?
That's the ignition module.
This is the ignition module. What is the pickup coil connected to? We got an orange wire and a purple wire here. We have an orange wire and a purple wire here.
Connected to the ignition module.
Exactly. So what is the answer to your question? This is what I'm going to show you. If I got a good module, I'm going to show you. I'm going to make this part fall right here on the table in a minute. That ain't hard to do. Well, we're not going to. Lawrence is missing too. Yes, we will. All right. Now let's look at number 4. All right. What is the term used to create high voltage using low voltage? What is the term used? Is it electromagnetic induction, electromagnetic magnification, electromechanic induction, or electromagnetic multiplication? Huh?
If it's using high voltage, you get low.
If it's using low voltage, you
Electromagnetic induction.
I think it's D.
No, it's not electromechanic or electromagnetic magnification. Induction. Jeremy was trying to reason it out. That ain't that thing. Induction is when you induce current in a winding. You remember I told you I could take this copper winding and I could hook both sides of it to a voltmeter and I could pass a magnet through that copper winding and you see voltage? You just got magnetism sweeping across copper coils. It's going to make one. That's how the crank sensor works. It's got a core. It's got wire wrapped around it, and it's got the ends of that wire hooked to the computer, and it's actually creating a signal and all that. Here's a little short story that I thought was kind of funny related to ignition systems. Back in the mid-90s, Ford came out on the Ranger with this EDIS ignition like what that Escort's got on it. And it's got a little ignition module that's mounted by itself. It's got about 10 wires going to it. And 2 of those wires come from the crank sensor. And the computer, that little box is a smart box. And the computer will request a particular ignition timing angle from this smart box, and they call it a spark angle word. And what it does is it decides whether or not to comply with that. And I don't know under what circumstances it wouldn't, but that's why they describe it. So EDIS, and I was memorizing wire schematics about these things, so I'd have to, and they don't hardly ever give any trouble. It's pretty well, the Chevrolet stuff was all junk, but the Ford stuff never gave any trouble. I'm just saying that for Jeremy's fun. Chevrolet stuff's okay. All right, but the point is, there's Rangers in there, and think about this now. So I've got a Ranger that comes in on the hook, and it's going into my service bay, and the stupid thing has no spark. It's got everything it needs in the way of power, ground to the module. I'm even going with my oscilloscope, and I hook up to the crank sensor, the gray and the blue wires coming, and I'm getting this. Which is what you should see. You're seeing a little sinusoidal wave. And I said, this stupid thing still won't fire. Well, I had another module that I knew was a good one, which is a good thing to test apart, so I plug it in, and it still didn't do nothing. And so about this time, this yo-yo comes in here, and he's this retired rich guy that's got a big, huge motorhome. And he says, the shop foreman and him come walking over there and say, hey, this guy just parked his motorhome about 3 weeks ago, and it was running just fine, and now it won't even start. And it hadn't been sitting there for 3 weeks. And I thought about it, and I said, you probably have ants in your relays. Because those relays, some of them little relays have got a little hole in the bottom of them for some reason or other, and ants love to get up in those relays. I don't know why. They can go anywhere on that vehicle they want to once they climb onto it. Because when we went out there, I could see these little tendrils of plant life that was touching the side of the motorhome, and ants crawl over those, and they get in there. And anyway, so I turned on the key and I listened for the fuel pump. This is an engine performance class. That's why I'm telling you this. You switch on the key and you see if you hear the fuel pump. If you don't hear, then you need to find out what's going on with that before you do anything else. You know what I'm saying? Listen for the dadgum fuel pump. I ain't heard nothing for a fuel pump. And so I go out here to the junction box under the hood, and I pop the cover off and find the fuel pump relay. And I pull the fuel pump relay out, just one of those with a little hole at the bottom of it. And I pop the cover off of it with my pocket screwdriver. If I didn't have a pocket screwdriver, I wouldn't be able to do that. Everybody's a pocket screwdriver, right? All right, and a flashlight. All right, so I look in there, and in between the points on that relay is a single ant. It wasn't like a cluster of ants that got in there, because sometimes you'll see ants. I've seen them climb up and get on top of a car battery and pile up 1/4 of an inch thick from post to post. They love that electricity. Your water pump out in the country that's pumping out of your deep well, and it's got that regulator, they'll get up in that darn thing and get in the point. Oh, yeah. Ants just get screwed up by that electricity. They get up in there. Well, anyway, he got in there, and there's one ant. And it couldn't carry nothing to the fuel pump. So that one little teeny tiny sugar ant, or whatever kind, it might have been fire ant, whatever. I didn't analyze the bug, but I knew kill that 10,000-pound motorhome sitting dead in the water because that one ant got between the points. The only place, of course, there's another place he could have got too. The power relay would have kept it. But the point is, I'm all patting myself on the back. Yeah, I figured this out without even seeing it. Yeah, baby. Then I go back in his Ranger sitting there looking at me. It's been kicking my butt. I can't figure out what's wrong with that darn thing. But you know what I did? I said, I'm just going to take and put an overlay from the crank sensor, which is reading off this tooth wheel. This is 36 minus 1 tooth trigger wheel. And up here on the other part of the thing is this module. If you're still reading that. All right, so I'm going to take these 2 wires that go here, and I'm going to go snip, and I'm going to go snip. Cut those off. Now that wire's still in there, and I got a couple of pieces of wire, and I put it in the drill, and put 2 wires in the drill, and I put the other 2 wires in a vise, and I pull the trigger on my drill, and it round and around each other. That's what you need on this ignition circuit. It needs to be, and it's got to be wrapped with grounded fall. That keeps it from getting fouled up. If you got this crank sensor wire running right next to a starter cable, a lot of times the car won't start, because it induces all kinds of screwed up stuff in there. So I said, I'm going to go ahead and just run another, an overlay. So with this wire that's in there clipped out, I spliced this wire, and I made sure I had two different color wires so I wouldn't have them hooked up backwards. Here's another thing. You hook the crank sensor wires up backwards, you'll see the RPM will go up to like 250 when you're spinning, and then it'll drop to 0 and you won't have spark. So if you hook them up backwards, you won't have spark either. Remember that. Most people don't even know that. But I wired that sucker up, boom, busted right off. So I made my overlay permanent by running it through a harness and all that kind of stuff. I don't know what was wrong with those wires. I wasn't curious enough. I'm in this to make a little money for the dealership and me and get the person's car fixed. Now, if I wanted to be a real yo-yo and dig in here and split the harness, I might have been able to figure something out, or I might not have been able to, because sometimes wires will have something wrong with them. You can see it. Even you can't measure. You can't. I've actually seen wires that wouldn't conduct electricity, but you couldn't find anything wrong with them. You know, so there's just crazy stuff like that happens. Anyway, that was a neat little ignition system story. And when I remeasured my signal before, I was getting, you know, this, and with the new overlay, I was getting that, which wasn't very much stronger, but there was a threshold that module was looking for its amplitude and stuff. All right, now let's go down here, and we are on number 5. Technician A says the primary and secondary ignition systems are never connected. What does that mean? What does that mean? Huh?
4 was A, wasn't it?
Yeah, 4 with A. Technician A says the primary and secondary ignition system are never connected. Technician B says the primary and secondary windings are connected in some ignition coils. Who is correct about that? Got your book? Now, remember your rule of thumb when you're taking any kind of a test, if you see the words always or never or only, you can usually X out that guy's answer. Usually. I don't care what kind of test you're taking. If it says always, only, or never, those are you know, game changers. That guy's dead wrong. One end of that winding is connected. Those two are connected in this little oil-filled coil I was talking about earlier. In the distributor ignition coils, like those two you see on that board over there, they're not connected to each other. What they're wired up like, and you can see it in a wiring schematic of an ignition system, you've got a core, and you'll see the secondary side, which spark comes out of both of them, and you'll see the primary side, like that. And they won't have any connection at all between those. That's on a distributorless ignition coil. You understand that? All right. Now then, so that's going to be a B, right?
Yep.
Technician A says the primary coil has more windings. Technician B says the secondary coil has more windings. What did I just tell you a few minutes ago on the board? Which one has more windings? The secondary has, that's going to be a B, isn't it? The following statements are correct except A, the direction of the primary windings is in an ignition coil determines polarity. B, when the ignition trigger is closed, voltage should only be available at the positive coil terminal. C, the primary windings of the coil should have continuity. Or D, switching to positive and negative leads to an ignition coil could cause the coil to produce a weak spark. That's a bunch of long words on each one of those, isn't it? So the direction of the primary windings, all of them are true except, right? All of them are true except. What happens if you reverse the polarity on your scope pattern? You ever notice that? You did the other day. When I reversed polarity, the spikes were pointing down instead of up. Did you know that my dad, when he was running his shop, could pull the, it was easy to hook the coil up backwards because you just had to plug on terminals on a lot of them. And if somebody hooked it up backwards on those oil-filled coils, it would make a weak spark. On these E-core and these, potted coils like we have that's got your, and you see some of the potted coils, like the E-core coils, it's just, even if it's only got, it doesn't have to be distributor. See, like the 87 Ford you got, it's got an E-core coil in it. You can reverse the polarity on that one, it won't make a dadgum bit of difference on how strong the spark is. On an oil-filled coil, it will. It makes it weak. My dad could look at that spark and tell you if the coil polarity was reversed, just by looking at the spark. And he got to where he could look and see the way that thing was pointing. There was a little finger of flame inside that spark. And he said, and he could look at it and tell. He just got to where he was good at that. You know, it's pretty interesting, I thought. My dad was a peculiar guy anyway. But I mean, he thought outside the box. He didn't think like other people, you know. And he fixed a lot of cars. So what did we come up with on that one? Who's the except? Is that a peculiar? The direction of the primary windings in ignition coil does determine polarity. When the ignition is closed, that's 7, isn't it?
Yeah, that's true.
The primary windings of the coil should have continuity. They should. They should. That's true. Switching the positive and negative leads could produce it. And I would say D is actually true too. B is the one. Hey, Lawrence.
Hey, Richard, like the one me and Wes worked on the car, it was producing backwards spark.
Was producing what now?
The polarity on was reversing, I had to switch it over.
We swapped it on the machines, right?
Yeah.
What polarity did you swap? I'm lost here. What's up with?
You're the one that me and Wes, I broke the cable on.
No, he knows I broke it.
Yeah, that one.
Look, watch it. Miss Richard, he said, watch it. I'm going to go tell Miss Richard.
I'm not getting good communication here. Okay, what polarity was it that was reversed?
We hooked the scope to the spark plugs.
Hook the coat? Yeah, okay.
Yeah. And it was doing, like you said, it was shoot the bars down instead of up.
Yeah.
Yeah.
Okay.
Then we had to flip it over.
Yeah. You mean you had to flip the switch, or you had to flip what?
We flipped the clamp over.
Oh, you did? Oh, I see what you're talking about. Okay, yeah. Well, say something else too. How many of you know you got your companion cylinders that are being fired by the same coil, right?
Yeah.
On some cars, like on some of these little Kias and stuff, and I don't know how many other ones there are. If you hook, 1 and 4 are firing at the same time, so it seems like it wouldn't make any difference, right? Because the one that's going to get the most of the spark is the one where the compression and everything is, and the gas is in there and everything like that. And the other one is kind of always kind of weak. If you swap those suckers around, cause the thing either to not start or run crappy because it's actually using compression sense. It actually some of them have the weird stuff. They put about 80 volts to the spark plug, and they look to see how that changes whenever you got compression. I mean, it's just strange how people are using, instead of using a cam sensor, they're sensing compression by the the way that the spark is channeled. You know what I mean? I mean, I don't want to go that too deep, but always make sure you hook those suckers up like they're supposed to be. That's the point. And they'll typically be marked on the coil, 1 and 4, 2 and 3, this kind of stuff. So if you hook them up backwards, don't be surprised. And also on these distributorless ignition cars, when you pull a code for a misfire on cylinder number 2, let's say, and you pull the plug and you look at the coil and you got good spark and everything's fine, your misfire may be on a different cylinder. So make sure that you don't, you look at all of them. Don't just look at the one that you're getting the misfire code for, because that will mess you up. I mean, in some cases. Doesn't happen a lot, but it can. Okay, so number 7 is going to be B. When ignition trigger is closed, voltage should only be available at the positive coil. I don't really like that question, to tell you the truth. That's supposed to be the one. I'm going to tell you what you will not see. You're not going to typically see voltage at the negative coil. And this one right here, this system right here I was holding up a while ago, whenever the ignition is switched on, but the engine's not spinning over, this thing has got the negative side of the coil dead shorted to ground. And you can only get away with that on an oil-filled ignition coil. If you've got an E-core potted coil and you dead short one side of the ground, then you're going to burn that coil up. Now, if you just leave the key switched on one of these all night long, I'm talking some yo-yo leaves the key on and they go home for the night, and then they come back and it's all out the battery's dead. They've usually just ignition coil because they've avoided it. See, so I've run into that before. All right. Now then, so that's supposed to be B. If you want your answer key to show you right, it's going to be B. I don't really like that because you're going to see voltage only on the positive side typically if that's closed. So B is what you're going to put on that one. Which statement below is correct? A, turning on the low voltage primary coil, high voltage in the secondary. Is that? What did I tell you? You're turning on the primary, you're saturated. You spark till you break the points. Right? Okay, turning on low voltage primary coil induces a high voltage in the secondary winding. There you go. All right, no voltage is induced in the primary circuit. You actually will induce some. You know when I told you about the the magnetic field collapsing? You're making thousands of volts in the secondary circuit. Well, you're actually also making about 400 volts in the primary circuit. And whenever you're fooling with if you're fooling with the points in a distributor that has points in it, and somebody is, or if they're over there touching the primary side, it'll jolt them a little bit. My boss man, back in 1977, I was working in a shop over at Enterprise, and me and him were working on a Rambler that was out there, and he was fooling with a coil over there, and I kept moving the distributor doing something. I was working on one side, and he was working on, quit. And see, it wasn't the coil wire that was biting him, it was the points. I mean, it was the points for inducing that load, that 400 volts. No voltages inducing the secondary circuit at home. So this is going to be 8 is going to be a B. 8 is going to be a B. Which statement below is correct? The primary coil windings are made of thinner wire than the secondary. That's not right, because you got more windings on the secondary, right? They're little tiny windings, the smallest thread, or smaller. The secondary coil windings are designed for higher current. Are they? The primary coil windings have more turns of wire. That ain't right. The primary coil windings are designed for higher current, 2 to 6 amps. Usually it was about 5 amps. That's what limited to. And so you're basically going to be looking at a D there. Finally, the number 10 on that text there. What is the name of the electronic component inside the ignition module that opens and closes the primary ignition circuit? What did I tell you? What? Transistor. It's got a transistor. That's a semiconductor. Remember when we were in our electrical test, if you have one free electrode, one electron in the valence ring, you got a really good conductor. It'll be something like gold or something like that. If you got a bunch of them, which would be like 8, it's an insulator. In the valence ring, it's a semiconductor. And diodes and transistors and that kind of thing are made out of semiconductors, right? All right, now we're going to move on to test number 11. And I'm going to show you all some ignition stuff here when we're through these tests. All right, let me get this opened up. Back in there. 11 and 12, I'll work it. Just going to need take a copy on that. That pump is going to have to be sent off to be rebuilt. If you buy the pump, it's $800. You send it off to have it repaired, it don't cost all that much, right? And it's going to take a while to send it off to get repaired. I hate to say that. All right. The following statements are correct except. Here. We're talking about ignition. It's going to be the chapter after the one you were just in. Yeah. The following statements are correct except electric conductive rubber hose can be used when testing some ignition system secondary circuits.
That?
Electrically conductive rubber hose. Is there? Let me show you a trick. Here's how you do this. Let's say, and this is something that happened in when I was at that shop in '77. There's a '75 Monte Carlo. It was quitting sometimes. And Mike told me, the go-to guy at that shop, he said, I'm going to have this Monte Carlo out Bellwood Road. And he says, if I'm not back in like 20 minutes, come hunt me. And I looked at my watch, got caught up in my tune-up, whatever I was doing. I said, gosh, he's been gone 30 minutes. I better go find him. So I got on the shop truck, which was like a 66 GMC pickup, and I drove over there, found him sitting out beside the road steaming, because I left him standing out there. So I said, he didn't think to take any, and this wasn't like him, I don't know what happened. He didn't think to take anything with him to check for the spark. And he had his pocket knife. Well, how many of you know your pocket knife, if you're using it to check sparks, will knock the crap out of you because it's got all this metal. There's a pocket knife kind of like right there, except it's a fatter one, And so he got in the back of the shop truck, and he got a piece of heater hose, about this long, and he cut that piece of heater hose, and he folded the blade out on his pocket knife, and he slid that piece of heater hose over that pocket knife, and he stuck that pocket knife up in a screwdriver, up in the spark plug wire, and he held it, by the hose and says, okay, go ahead and spin it over. Well, the connection at the bulkhead had come back together and decided to work then. And when I spun it over, that thing lit him up. Well, the reason is because there was fiberglass in that heater hose, And I'll tell you something else you can do. There's one instructor, that is an automotive instructor I was talking to. He took a piece of rubber hose, exactly the same size as a spark plug wire, and he pulled the spark plug wire ends off, and he put a piece of rubber hose in there and ran it, a piece of rubber hose with spark plug boots on. It looked like a spark plug wire, but it's just a paper hose. And he put that thing on there, and he was going to make a skip and make them have to hunt a skip. You see what I'm saying? And he fired that thing up, and it was hitting on that cylinder. That hose was carrying a spark. It wasn't going through the air in the middle of the hose, it was going through the rubber.
Right.
But the point is, rubber hose will do a lot more than you think it will. A lot of times, if you hold a spark plug wire over close to the rubber hose, it'll jump and hit that hose. Doesn't seem like it would. You know what I mean? I always hold it close to metal. Now, it won't jump and hit plastic, but a piece of rubber hose, a lot of times, got conductive elements in it, and it'll do that. All right, yeah. And so, think about that. The next one is oil and dirt may cause high resistance in electrical connection. Okay, that sounds feasible. Incorrect routing of secondary ignition wires may cause electromagnetic interference with computer circuits. Is that true? All of the above statements are correct. That's a D. That one is a D. Now, we talked earlier about the firing order on some of these cars and how if you're wanting to be a good mechanic and make a really neat looking plug wire loom, if you run two wires that are next to each other in firing order, right next to one another, the one that's firing earlier will induce a spark in the one that's not firing, and it'll cause it to fire when the piston's on the way up. And it'll labor knock on that cylinder, burn the dadgum spark plug up, make it ping. If you got two wires, like let's say on a Chevrolet, you got two wires in a firing order, and two cylinders that are right, and those two cylinders are right next to each other on the engine, right? You remember that? What's the firing order on the 350? Somebody in here probably will know that. You remember?
1357246.
Oh, come on, man.
Oh, the firing order.
Yeah.
Man, I'm thinking about that.
That's you're talking about how many cylinders number?
Yeah.
Okay. What? 1843657 Got that? Okay, so if I'm going to draw these holes, where's number one? If the fan,
Right there.
if this is the front, number one is here, right?
Yep.
Okay, 1, 3, 5, 7. I should have made that one like that. Look at 5 and 7 are right next to each other. They're also right next to each other on the firing order. And the danger is, if somebody puts the spark plug wires on there, they're going to route them spark plug wires right next to each other all the way to them two cylinders. Yep. And what happens then is when 5 fires, it creates spark because of they're running so close on that inductive magnetism that your scope is reading. It actually is going to create a spark in that number 7 hole, and the piston's coming up, and it ain't ready for a spark. And a spark happens, and there's already a mix in there that's charged, and it goes bam, and it tries to stop the piston. It rings it like a bell, and and that's a pinging, sort of a skip kind of a thing you'll experience. And so that's one of the things that can happen on a Ford or a Chevrolet or any other. Now on some of these Dodge pickups like Greg's, the coil wire is a really long son of a gun. The coil is mounted on the front of the right-hand cylinder head. I'm talking about the passenger side cylinder head. And that coil wire runs all the way back to the distributor. And they originally ran it right next to a bunch of them other wires. And there were some problems with this kind of crap going on because the coil wires, popping every time. And it was inducing a spark that wasn't needed in one of those wires at the wrong time. And we would have to reroute that coil wire above the valve cover to get it away from that other wire. And that was on some of the Jeep Grand Cherokees and stuff like that. All right, now then. Let's see, so that was going to, huh?
What you supposed to do about them?
Oh, what you're going to do, I should have told you that, I'm sorry. What you're supposed to do about those is when you're routing the wires, let's say you would ordinarily have these two wires that would be running right next to one another. What you're going to do is you're going to run them so that you got 5 here and 7 here with 2 other wires in between them. That takes care of that problem. And your computer timing circuits, if they're laying real close to the wires, that'll make it run bad too. All right, so like where you unplug the wires to set your timing, you don't want it laying close to your wires either if you can help it. All right, now you got number 2. Technician A changes the position of a waste spark ignition coil to diagnose an ignition misfire. In other words, he's, I guess, moving the polarity of the wires. Is that what you're talking about? Technician B says a defective coil should cause problems on the cylinders it's connected to. That is a kind of a crazy question, isn't it? A defective coil should cause problems on the cylinders it's connected to. All right, let me ask you this. You got on a distributor's ignition system, we're just going to make this real simple. We got 2 towers, and they're feeding companion cylinders, 3 and 4, right? And of course you got the computer firing those. Is it possible if this whole coil is bad, you're going to lose both these, right? Is it possible for this coil to go bad and lose just one of them?
Yes.
Because these are actually inside here. You have that, and you got a core, and then your primary trigger is coming in on the other side of that core. So how is it possible that I can lose just one tower and not the other tower on that same coil? That's an important question.
So there's two primary coming in?
There's only one primary coming in that fires both of these. You got two secondaries coming out. This is like an old motorcycle coil. And you got just the primary. You got the power coming in and you got a trigger. All right. Is it possible for it to lose just one of these? Yes, it is. And it happens all the time.
How is it possible? What I was thinking is, what if one of the, like the right side?
It actually develops a breach between the winding on this side and that little core. And it goes pop, 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 pop. It's popping down inside here, or maybe popping to the screw that goes through the coil that mounts it. And this one over here is just popping up a storm. And we were told early on when distributorless ignition first came out that if you disconnected this one, that one would also misfire. But it won't. This one here can keep firing even if you've got that disconnected. Even though the way the thing is drawn, it has to be a full circle. It's still going to go find somewhere to go. High energy voltage is going to find somewhere to go. High energy, like firing voltage. So that's going to be a C. Number 2 is going to be a C. Anytime you've got a cylinder that's misfiring, let me say this because this is an engine performance class, and let's say that you're suspecting the injector, but let's say they don't have an injector in stock, or the injector they do have in stock, they're not going to take it back once you tried it and it's $186 for the injector. What are you going to do? I'm going to take the injector from one of the other cylinders that's not misfiring and swap places with that one and that one. And if the skip moves with it, you got an injector. If you swap, and you'll be surprised, you'll swap that thing around, the skip will stay in the same place. And now if you'd have gone to the parts room, now it may be a pain in the butt. It may be up under the intake manifold, up under the the plenum on that one side where you got to pull that off. But you may as well go ahead and do it. Let's make sure that we're as surgically possible that we fix the car as we can be, instead of just saying, well, I think I'll throw a cam and crank sensor, I think I'll throw an ignition module, I think I'll throw these relays at it. And then they come over here and they say, hey, they spent $725 of my money at this other shop, and now my car still ain't doing this any better than it was. And then somebody finds a wire that's short and tapes it up. I've done that before. Worked behind another shop, and there's a wire harness dragging across a bracket shorting out, and they changed every part on that motor. Charged that guy all kind of money. He went to this shop and that one and the other because he thought he was going to get screwed when he went to the dealership. And I walked out there to his van in the parking lot and looked at it and pulled it back and taped it up and put a tie wrap on it. And I think his bill was $20. You know what I mean? But I mean, if you're serious about doing this kind of stuff and you want to fix somebody's car, if they come to you and they get good answers, they may not always like the answers they get, but if you give them solid, right answers, you're going to have repeat customers, and that's just the way it is. And I say repeat customers a good way, not people that come back because it wasn't fixed right. Okay, number 3. Crankshaft sensors may either be magnetic pickup sensors or Hall effect sensors. Now, what is a Hall effect sensor? Does everybody know that? Anybody know what a Hall effect sensor is?
Also using a stationary sensor and a rotating trigger wheel.
Well, I'm going to temporarily remove this from the board. If I can get that number 2.
Where'd you find that at, huh? Like 263. 263?
Let me get that off there. I can cut them. Hurry up. Get that thing off of there. All right, hang on to that. Let it fall off on us. I'll have to demo that in a few minutes. Don't let it fall off. Okay, this right here is a Hall effect sensor. If I take this piece out, you look down in that distributor, and you're going to see that you got a magnet, and you got this little sort of a return metal piece, and on this side in there, you've actually got a little semiconductor, and when you shield, if I was to hook this up to that where it would fire that coil, and we can do that, and I took a hacksaw blade or my pocket knife and I stuck it down between there, it would go pop, 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 fire the coil. That's what these blades are about. These blades whirl around and they go between there, pop, 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 pop. Then your rotor sorts out the spark by pointing at the proper terminals under the distributor cap. That's why your firing order's got to be right on the distributor cap. See, that ain't complicated. Now I notice on this particular one here, one of the windows is a slightly different width than the rest of them. That's like what the Ford was using for a cam sensor, signature PIP. That's what they call that, profile ignition pickup. That's the ignition module on one of these, and it's got 6 terminals in here. And that bottom one is ground, and the top one is profile ignition pickup, feed to the computer, which is reference, and it uses it for fire injectors and all that kind of stuff. The one that's closest to the ground down there is your coil, goes to the coil, fires the coil. And the two next ones, one of them start and one's run, and then the one right under there is your spark output terminal, which is when you unplug that, it takes the computer out of the loop. Okay, so there's a distributor there. This is the kind of stuff that you guys need to know. And I'm trying to keep it as interesting as I can here, but that's a Hall effect. Now, crankshaft sensors may be either magnetic pickup or Hall effect. Now, a Hall effect sensor doesn't always have this kind of arrangement here. It can be just reading a tooth that's going by it. You see what I'm saying? If it's got 3 wires going to it, it's typically going to be a Hall effect sensor. If it's got 2 wires going to it, like one of them, it's going to be variable reluctance, and it's going to create. Hall effect sensor creates a square wave signal. Meaning the square wave signal is when it on your scope is going to look like that. And a 2-wire sensor will create that. And then you got piezo-resistive and magneto-resistive sensors, and that's a totally different world. You use them for wheel speed sensors and stuff like that. All right. Engine speed and position sensors only affect the ignition system. Yeah, that one there is not right. Okay. Defective crankshaft sensors may cause the fuel system not to operate properly. Now we're looking for the correct statement, right? So crank sensors may be magnetic pickup or Hall effect. That's true. Engine speed and position sensors only affect the ignition system, and he was saying earlier that was false, right? And then the D was an ignition module should be replaced if it's not switching the ground circuit to the coil or supplying the coil with battery voltage. Listen to this, guys. While I'm thinking about this, I'm going to tell you. You're looking at one that's got a coil, even if it's got distributorless ignition. You got one, like if it's got that one, this coil pack right here. One of these wires, one of this coil pack right here, this has got a broke thing on it, is going to be hot, and the other 3 are going to trigger the coils. So as it triggers the coils, just pop, 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 pop. These coils on fire. Let's say that you got one of them that's not firing. See, I could go out here to this Ranger, and I could jimmy one of the wires going to one of these, and you'd lose 2 towers. And you might think it was a coil. It's kind of silly to replace a coil if you hadn't at least taken your test light and gone into the trigger wire. Each one of these 3 triggers, the red one's going to be the hot one that's feeding the coil. You go into the 3 triggers with your test light, you'll see a pulse coming from the computer. Remember, like we did on the If you don't see that pulse, then you'll know that either your driver in the computer is bad or the wire between there and there is bad. Got that? So all these come straight from the computer typically, right? So that's what you need to be thinking about there. Take your test light and look at your 3 trigger wires, see if they're pulsing. If they're not, if one of them's not pulsing, that's why that sucker ain't firing. If they're all 3 pulsing but it ain't firing, you got a bad one of these. Usually, though, when you get a bad one of these, you won't lose both of these. You'll just lose one of these. That's what I was talking about earlier. This one will quit popping. And these things right here, my gosh, they'll jump as far it scare the daylights out of you. Then we need to be careful about that. Now then. So that one there was going to be a B, right? Okay, Technician A performs a thorough visual inspection of the ignition system, and B says electrical energy from an open secondary ignition wire can cause property damage or personal injury. Who's correct about that? Both of them are. And I tell you what, if that little escort out there is idling and the engine's warm enough to where it's firing that coil 3 times every time it pops it and it reaches out and touches you, you will bang your head on the hood and you'll hit your knee on the fender and you'll stagger back for a way or 2. And I've seen people do that. All right, so Donnie was doing that. Donnie's over here reaching over here, and this thing happened to get him on working on an escort. And he goes, wham, bang, and hits his hood, and it just about put him out. I mean, that thing was, this is 110,000 volts, 3 little jolts of it, and knock you silly. You better be really careful about that. You can die. If it runs across and stops your heart, you're dead meat. Okay, now then. All right, number 5. What term specifies the order spark reaches the cylinders? Fire and order. That's not hard. Number 5 is a D. Okay, which of the following could cause poor engine operation or no start?
All of them.
And all of the above. Technician A says platinum tipped spark plugs should never be regapped after using in a running engine. Did you see that in your book anywhere? Technician B says spark plugs should not be removed from a hot cylinder head. Okay, let me ask you this question here. Let's say that you screwed your spark plugs out, you did a compression test, you screw the compression gauge in, you check your compression. Now, let's say you're going to check running compression, which you can do. Crank it up, and you let it run for a little while, and then you switch it off, and you go to talk to the service manager, maybe get you a Coke or whatever. You come back, and now your dadgum compression gauge won't screw out of there.
So it's stuck. When the body expands, when it won't cold, cools down, it contracts.
Yeah, and I know, but you got to get it back out of there.
Warm the car back up.
Yeah, crank it up. Just warm it back up and let it screw out of there. You can do that, and that'll open it up like that. So number 7 is actually a C, by the way. According to some of these people, you should never regap platinum spark plug. Now, what I always think about in a situation like that is, what are the consequences if you do?
What happens if you regap platinum spark plug?
I just regap them if I want to. I mean, I could be wrong, but if I decide I want to regap a platinum spark plug, I'm going to regap that sucker. What's going to happen? Is it going to destroy the engine? I mean, if it causes the spark plug to fail and makes it misfire, it's always best, really, if you got any doubt that a spark plug. And I checked when I was checking the electrode resistance in the center of the spark plug, from the top of the plug to the center electrode in the plug, and I wrote about that in a Motor Age magazine that I was doing. I use that as a troubleshooting tool, especially on these coil-on plug ignition systems. And I've seen them have as little as 200 ohms, which ain't worth a darn. I've seen them be wide open, which is not good.
How much? How many?
Less than 8,000 ohms, according to the training material that I've seen. And what was funny was the people at the Champion Spark Plug. There's one of these engineers from Champion Spark Plug sent me a nasty email after I wrote about that in a Motor Age article. You're not supposed to check resistance or spark plug with a meter and all that. And I said, well, Ford Motor Company has it in their training stuff. They show a picture of a meter checking a spark plug, and they say it's supposed to have less than 8,000 ohms. I want them to be all pretty much the same. Now, what was funny was I got a brand new set of Champion spark plugs, laid them out on the bench, and then we were going to put in something, and I was measuring them just to see what I'd get. On some of them, I'd get 2,000 ohms. On some, I'd get 18. Now, I'm not carrying on a campaign here against Champion spark plugs. I got Champion spark plugs in my Jeep. It ain't a big deal. But this guy didn't like me measuring the resistance, because in his mind, that wasn't a good way of testing them. But I'm going to do it, because if I see something I don't like, I'm putting another spark plug in there. If your coil-on plug coil has failed on one of your holes, you'll see that. If you let these Ford pickups idle a lot, and those plugs are having to fire 3 times every time they fire, the coil, you're liable to wipe the coils out. Taxis and stuff, if they idle a lot or travel real slow in traffic, they lose, the coils drop out and they go bad. So what they have to do is put coils in there. You're going to see that in the pickups. And if you got some yo-yo that's letting his truck idle a lot, he's going to lose. More coils are going to go bad than if somebody's driving down the road. That's just the way that is. I mean, I'm just telling you that. You may not hear that anywhere else, but that's just what I've experienced. And so that's what we got to look at. Furthermore, if you're changing out that one coil, pull that plug out and measure that sucker. It's a good idea to throw the plug in there anyway. When you're doing a tune-up on one of these that's got coil-on plug, like on some of these Fords, you can get the boots for the coils. That rubber boot that's on the coil? Mm-hmm. Get those. And, put those on there along with the plugs. Sell them those too. Let's go ahead and put you some boots on there along. Easy to do. Pop them on there and stick them down in there. Not a big deal on that. I mean, there's no reason not to do it. If one of the spark plugs is misfiring and you see a lot of rust around that spark plug, look for a heater hose that's dripping on that coil and going down in that hole. Because if this coil is potted, and it doesn't look like it's going to be hurt by water dripping on it, but if you got water dripping on that coil from a heater, it's going to destroy the coil. Seen it too many times. And sometimes the heater hoses are running up there where if the clamp's not tight, they'll drip on a doggone coil. Like the number 4 on like on an Expedition or something, 5.4, like a truck that Jeremy's getting ready to work on for the rest of the day, putting front end parts on. All right. Now then, let's see. what we got here, what question? Number 8. Which of the following would cause carbon foul spark plugs? Carbon foul spark plugs. He was looking up there. Rich fuel mixture. That's actually soot. We would call that soot.
That's why I looked at that.
Yeah, hydrocarbons is unburned fuel. It's a good thing. That's what that chart's up there for. Which of the following could cause oil foul spark plugs?
B. Personal experience.
Yes, they could. But I tell you what usually is, what that causes more. Everybody look at that picture right there. See that ice cream looking stuff that's on that plug? That is valve stem seals. When you see that, that is a valve stem seal concern. That's what you're going to see. You're going to see valve stem seals. If you pull plugs out, valve stem seals is the name of the game. That's about all they call that.
I've never seen that.
Yeah, you'll see it. If you keep going, you may drive a car that's got a surge to it. You may unplug the EGR valve, the surge may go away. And you may think, oh, I've got a bad EGR valve. And you throw an EGR valve on it, that ain't it. And you pull all the plugs out, and you see that crap on the plug. And when EGR is flowing, it causes some of them to misfire when they've already got a handicap like that. You see what I'm saying? And let me whirl my video around here, and I'm going to show that so that anybody that's watching that can see it. I can make that zoom in on that one thing I was talking. See that? You can see them ice cream looking deposits. That's what I'm talking about. I do not answer the phone most of the time when I'm giving one of these lectures. Okay. Now then, Technician A says defective wires, distributor cap, or ignition coil can often be found by looking for a leaking spark while running the engine in the dark. If it's dark, that was this guy that's going out there at the Ford, Philip Kirkland. He was a guy that worked with me. He says, I was out there trying to check for spark on that car I was checking on the service light, and the sun was so bright I couldn't tell if I had spark or not. And I said, well, you needed one of them SSTs. Huh? SST, shaded spark tester. I made that up. There ain't no such thing. I think I might design something like that. But anyway, but you look at it dark, you're going to see it better. Technician B says a mist of water from a spray bottle can be used to find defective secondary ignition components. If you're going to spray something on there, make sure that whatever you spray on there's got some soap in it, so it'll break the surface tension of the water and it'll go into those cracks. If you're spraying that water on there, though, sometimes you'll see what looks like spark jumping, but if it don't start the engine to skipping, then you ain't found nothing. You know what I'm saying? You can spray it on a wire and you may see a little red spark happening, but if the engine's still hitting on all 8 cylinders or all 6, you're okay. But if you spray it on there and you see pop, 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 something else you can do, like on this Toyota engine we got out here that's got them long plastic spark plugs going down in the head. If you pull them back and you see a spark punching through the side of it, you got a bad wire. And you probably, if the spark plugs get old enough to where the spark starts hunting somewhere else to go, it's going to go somewhere else. Once it punches a hole, it's easier for it to go there than it is anywhere. So you don't have a misfire on that cylinder. It's just the name of the game.
Would that be C?
Yeah, that one there is going to be,
B.
yeah, you can go a C on that. All right.
Find in the dark, look for it.
All right, finally, we're going to jump into number 12. Chapter 12. Huh? Now we're rolling, we're actually looking at sensors and stuff, and computers and whatnot. You see that? You see your next chapter?
You know, change chapters in the book, it goes ignition timing and then you go knock sensor on the same page.
You got some sensors there.
Yeah, I'm saying it goes chapter 18.
Huh?
Chapter 18, computer and network.
Yeah, and I've got other semesters where I teach some of those other things, and so I basically just used the chapters that were the most pertinent to the course I'm teaching this time. Which component listed coordinates engine and transmission operation, processes data, maintains communications, and makes the control decisions needed for the vehicle to keep the vehicle operating? That's the PCM. Now, why is it that Dodge and Chevrolet can call some of their computers an ECM? They don't have to call it a PCM. It doesn't control the transmission. Like on a Duramax diesel, It doesn't control the transmission. They got a separate computer for the transmission, you see. So you can call it an ECM if all it's controlling is the engine. GM called theirs an ECM for a long time. I mean, for years. Ford called theirs a processor and one thing and another. Which term describes the electrical potential used to communicate?
Voltage.
Voltage. Electrical potential is voltage any way you cut it. Which computer function is defined as a storage signal from a sensor or switch? Which computer function is defined as a voltage signal from a sensor or switch? Yeah. Well, it's when you're it depends on what you're talking about. It's output from the sensor, but input to the PCM. The PCM is the master of the house, and so it's either going to be going PCM or into the PCM. Sensors are coming in. I'll tell you something else you need to learn how to do is you need to learn what sensors can cause, what inputs can cause what to change. Be able to think logically.
Output, but
Yeah.
if it was going into the going into the PCM would be input.
If it's from a sensor or switch, it's coming into the computers. That's what you're talking about, isn't it? Number 3. Yeah, 3 is A. I'm sorry.
3 is A.
Did I say 3 is wrong? Did I say something wrong? I'm sorry.
You said
I
3
fouled
is
up on
C.
that. And so which computer function describes how the computer handles inputs? Anybody know? Is it output, storage, input, or process? Mm-hmm. What term describes the task of cleaning and amplifying input voltage so it can be understood by the computer?
Input induction.
Yeah, it's not too hard, is it, Greg? It's not pulse width modulation. It's not read-only memory. It's not input conditioning. Which computer function describes keeping information in electronic memory? Yeah. See, that's what this part is really easy, isn't it? The following statements are correct except ROM can be changed by a process called reflashing. ROM contains information that changes frequently. Now, one of the things that I don't like, about this read-only memory, they typically will have, they're going to call that one the reflashable one, or just EEPROM. Either way, whatever. You know what I'm saying? So, read-only memory means that you're not typically not going to write anything to it, electronically programmable read-only memory. ROM retains information even if there's no power. And ROM stores instructions for the computer that's considered permanent memory. What do you call memory that doesn't get lost when you unhook the power? There's a name for that. You've heard it before, you just hadn't let it burn in. Non-volatile. Non-volatile memory. If it's volatile memory, when you dump the power, you lose it. You know how a PC works? The guts of a PC? Okay, how would you describe your RAM? If you was going to explain it to somebody, they had no clue what you were talking about, how would you describe your RAM?
Random access memory?
Yeah, well, that's the name of it. But, I mean, I'm your girlfriend. I don't know nothing. I mean, I need to know what RAM is. I mean, what's the RAM over there? Why is it, I don't have random access memory, what's the deal? I don't understand. This is the way you describe that. Random access memory is your workbench. Where's the processor load where does the computer load the operating system when you boot it up? Oh, it goes into the RAM. The RAM is where the operating system is loaded when you boot it up. Yeah, most people don't know. They think it's running it off the hard drive. Heck no. Hard drive is a little too slow for that. RAM is instantaneous. See, so that's your workbench. So what you think about what you're doing, you got a workbench here, like a table here. And whenever you boot your computer up, you're putting your tools on your bench. First thing I'm going to do is I'm going to load my operating system. I'm going to put all this stuff right here. And then I'm going to put the other programs out here on my table. If you get too many programs running, it has to say, well, I got overflow, so I'm going to put it back, use some of the hard drive for memory. But why is it that it speeds the computer up when you put more RAM in it? You got a bigger workbench. And the RAM is actually faster reading than the processor. Okay, so I just wanted to throw you that because we're talking about computers here anyway. And I don't know everything there is to know about computers, and I don't think anybody does. I know a lot of people that are really sharp on one part and they don't know nothing about the other. Software guys, hardware guys, people that know networking really good and all that kind of stuff. And my son Luke said that he does network. He does the kind of work Cobb does here. Information technology for Georgia Iron Works up there. And he said somebody will build a couple of computers at home and they'll manage to get them to work and they'll put together a home network and they'll think they're ready to be an IT person. He said that's a joke, and it is, man. He can get kicked around bad trying to do that kind of stuff. You got to have training. He actually went to college and learned how to do all that, and it's tough work. Anyway, it sounds like it's fun and easy, but boy, that'll beat you up. So let's see. Technician A says information stored in volatile. What did I just say? RAM is lost when the power is turned off. That's what's happening with your computer. You reboot your computer here, the one like I'm using here, if you want to start over. Let's say everything in your RAM is sort of stacked out of shape and getting corrupted, and you're needing to fix that. You reboot, right? And when in doubt, reboot. Technician B says information stored in non-volatile RAM is lost when the power is turned off. A is right, B is wrong. Which computer process describes sending voltage commands to other modules or actuators? All right. Which component listed allows the computer to use a small amount of electrical current to control a high current circuit? Okay, that's going to be which one are you talking about? Small amount of electrical current to control a high current circuit. That is actually going to be what, a relay, right? Good 10, that's a relay. You got a teeny little tiny wire going to that relay, and it's got big fat wires that are going to run the fan. So a teeny little, or the little wires going over there. And by the way, I don't know if anybody y'all knew about that, but whenever Crystal was in here yesterday with her Honda car, the wire that goes between the relay, the fan relay, and the fan, it was like it was, I don't know who cut. I ain't saying it's cut. It's got an open circuit. So I mean, I could not get it. The fan would run when I powered it up, But whenever I checked it for continuity, there was nothing there. So she'll have that back in there. We'll have to fix that. Probably an overlay. But which method of digital switching lets the computer vary the length of time the signal stays on?
PWM.
Pulse width modulation. Pulse width modulation. You got that? All right, number 12. This test has 15 questions in it. The ratio of time relative to the period of the complete cycle. What's that? That's the duty cycle, isn't it? Which data set contains only 2 digits? Binary. Now we actually went through binary code in automotive electronics, and it's not complicated. Which circuit in a computer changes continuously variable information into binary information? 14. What'd you say, Greg? Analog to digital converter. That's right. The General Motors was using those in the early 80s whenever they first started. The computer really doesn't like an analog signal worth of crap. So basically it has a formula so that when the voltage in an analog signal goes above a certain level, it causes it to be an on or an off. And below a certain level, is off, and above a certain level is on. Which component could be considered the heart of the computer? The CPU. What does that stand for? Central Processing Unit. I think Schwarzenegger had one of those in his head on Terminator. All right. All right. Sorry for